Here's the idea. A lot of words here, but kind of the bottom line is if you've got some reaction that's at equilibrium and you mess with the equilibrium in some way, either by changing concentrations or pressures or change the volume, you disturb the equilibrium, and then that reaction will proceed either direction to reestablish the equilibrium. Like the problems I had you do before, that number that you give KC, that tells you the product-reactant relationship. So you disturb the equilibrium by changing the amount of products or reactants or in some way messing with it. That equilibrium number has to be reestablished. What Chaudiet's principle says, it will shift to reestablish the equilibrium. Whichever direction it needs to go. So it will matter, but that's based on what your equilibrium number is, so that it reestablishes whatever number.
So does the baseline of the equilibrium shift? Or does it do whatever it takes to get back to the initial equilibrium?
So
like if you're at equilibrium here and then you add something and you go up here, does it come back to here or does it change for the equilibrium?
all right, answer Rosalie's question. Back to if that's the number that's at equilibrium, and when you multiply all these together, you get that Kc equals, and this one was 2.256. If I take all of this away, what direction does the reaction have to go? That's what the question was asking. And the answer is if I remove this, the reaction goes to the left. If it goes to the left, what happens to the amount of the reactants? It increases or decreases? Decreases. And it will decrease until such time as, at this same temperature, that equilibrium number, when you do the math, is reestablished.
So it's trying to get back to that number?
Yes.
It doesn't change what that number means or what equilibrium
Because
the reaction is?
At a given time, and this is one of the multiple choice questions I want to mention here in a few minutes. But this number is the Kc at 483 kelvins. At a different temperature, you get a different K.
And so it finds a different equilibrium number.
But you will get different equilibrium concentrations that when you do the math with the square and the not square, it gets back to this number. Either way though, to reestablish equilibrium, this goes down, this one would go up. And it will do that until this number is reestablished. That's the Chaudiet's principle. If I add a bunch of this, what direction does the reaction move?
To the right.
To the right for you guys, it's that one. Okay. And it moves it to the right, and it will do that same thing, it'll move it to the right, so that this goes up and up until this is reestablished. Conceptually, is that okay?
So
Rosie?
you say if you change the system by like heating it or the pressure of it, doesn't that change the concentrations? Then wouldn't it give you a different Kc anyways because you're changing?
If you change the temperature, yeah.
Yeah. What about the pressure? Or is it?
Pressure
I thought
should.
pressure and concentration were like the same thing.
Yeah. So you should get the same. The temperature is going to change the K. Pressure won't, because pressure and concentration is the same thing. Okay. All right. So how about this question? For letter A, if you add oxygen, yes, you remember? A, C, or D?
A.
A.
Who says A? You see like all your hands go up, right? Okay. How about if you take out an O?
C.
Okay. Anybody say A? Anybody say B? C? Okay. Alright. Let's see. This one, if the volume is increased,
Like the total volume of the system.
just make make the container bigger.
B.
B.
Wait, what?
Oh, is it because of the number of moles of
Look at the number of moles of gas.
Oh, two.
How many moles of gas on the right?
2,
How many moles on the left?
3.
3 on the left, 2 on the right. Okay. Increased volume favors more moles of gas. Decrease. So if the question were rephrased, if the volume is decreased, that forces the reactants closer together. They're more likely to react. Pushes it to the right. Okay. So increased volume favors more moles, the side of the reaction with more moles of gas.
3 on the left.
3 moles
So
of gas
if
on
it
the left.
favors it, then that means it goes to the
Yeah,
left? Okay.
makes it move to the left.
I guess I was just confused about that.
What about this one? So, read the question, read the answer. What do you think? Does that so I'm saying, yeah. Do you agree because it's highlighted in yellow, or do you agree because you know why it works that way?
So it's basically like the one before it, in a way.
Yeah.
Why is the
Because-
calibration end of? I thought X.
So I'm guessing Elizabeth, you're just like it's boxed in yellow, so I agree with you. Which side? So first question: which side is more energetic? Particles, left side or right side?
Right.
You should be able to say the right side is more energetic, left side is left. Gases have more than liquids. If I were to make water as a liquid turn into water as a gas, do I have to add energy or remove energy? You add. I mean, anytime you boil water in a stove, I'm going to put plus energy over here. Okay. So if I take energy, add it to liquid water, it turns it into gaseous water. If you're in a system that's at equilibrium, and then I add energy to disturb it, where am I adding the energy? To the left side or the right side?
Left.
It's over here. And if you add energy here, what does it do to the equilibrium?
Sends it to the right.
Moves everything to the right. Okay. Anybody ever noticed, and I know I mentioned this before, one of the classes, why ice in your freezer slowly gets smaller? You notice that?
It's slowly shrinking.
So somehow my
We didn't
kid
talk about it.
managed to, I don't know what he did, but I've got a big old ice chunk that's in the automatic ice maker. So it won't rotate and flip everything out. And it's been like that for like 3 weeks now.
Why don't you just pour some hot water in there?
Because I don't want to make a mess inside the freezer.
Well,
Is it removable?
And it's removable, and I can get in, I can take it out. And I
But
got
you
everything
just-
on at the time. But I know this happens, okay? And I know that just opening and closing energy goes in, and as that happens, it pushes this reaction to the right. So over the course of the last 3 weeks, that chunk of ice that's clogged up my ice maker is getting smaller and smaller. So sometime in the next 2 weeks or so, if I decide not to take the stupid thing apart, and then run hot water over it outside the freezer, that ice chunk will get small enough because the solid ice turns into gaseous water, and it'll actually flip that thing around, and then I'll have ice.
It'll do the work for you.
It'll do the work, yeah, it does work for me. I don't need to worry about it. You just can't take the ice bath when it's done with swimming 8 miles or whatever it is to practice. So,
Well, it's his fault.
it's his own stupid fault. I actually had to go to the grocery store and buy him 3 bags of ice last week. So he can take an ice bath. Yeah, he swims year round, and last week they started the long course season, so his coach made him swim about 7 miles, 2 hours, 2.5 hours.
I can't.
So he came home from practice and he was,
How many laps
he was a little
is that?
sore. A lot sore.
How many laps is that?
A lot. I don't know.
7
40
miles.
40 laps to a mile.
Yeah,
Oh my
it's-
gosh.
280.
Oh my goodness.
But they're on a 50 meter pool, so
Oh.
he's swimming anywhere between 9,500 and 11,000 meters before practice.
Holy smokes.
So he's in good shape.
I bet.
I can't swim like he does. It's great. He swam a mile last weekend in 17 minutes or something. Okay.
Does he literally do anything else other than swim?
Yeah, he's in jazz band and
No way. What does he play?
tenor sax.
Nice. That's cool.
Jazz band, gets good voice.
How does he have time for jazz band?
It's time for sleeping later.
My father
Jazz
likes
band
that.
takes so
Yeah,
much
it's
time.
like me.
I have friends who like jazz band. They literally do not do anything. It's jazz band. They're like in band, then band after school, before school.
All right, these are in no particular order. I'm going to pass these out. I want to talk at least a little bit about a couple of multiple choice on here. Yeah.
Did you put them on a curve?
No.
Or maybe he shouldn't have. I'm really nervous.
Yeah.
I have all of it afterwards. But somehow in my head, like, I keep reading it and watch it, and I listen to it, right? But it's just, I don't know. It doesn't come, it's just not clicking for some reason. I don't know, like, what about it. Like, I mean, it's really straightforward.
I guess it's like, you can't like think of the questions that maybe you might ask until like you're at home trying to do the work or something.
Well, like, however I'm visualizing it is, like, the opposite.
Right. It just
It's like, but it means it's easily fixable.
yeah, true.
Just have to figure out what's wrong.
I guess yeah, like I think that's something that like a lot of people have an issue with is like I sometimes I feel bad in my physics class because I ask so many questions and then everyone else is like they're like thank you for asking those because I was confused and I didn't even know what to ask.
I have not. You took yours?
I took it.
Okay.
I haven't picked it up
Can I
yet.
ask a question, please?
Hang on.
Okay.
Tony.
You're like,
I don't want it. I saw this forward and I was like, ooh.
Do you know, okay, so I know right here I didn't actually convert it, but in my calculator I did, and that's the number that I got again. Because like, I multiplied this when I did it with joules.
That's the number.
So I wanted to transfer that to kilojoules. The
You want
8.31.
that number.
Yeah, but then R
So
is in
134.
joules, right?
No, but so you kept this number there?
Oh,
So
did
you
I
would-
write 147? Where the heck did I get 147? What the heck?
Right, like I'm looking at my watch.
No, because I wrote the right number here, and then I wrote 147
I know.
right here. Oh my gosh.
My number 3 is
Right.
No, hang on. Oh, let's see.
Right. Seriously, didn't we?
Kinetics on the first one. I think multiple choice wise. Has anybody wanted to see multiple choice on the first one?
Can you freaking
Here are the answers for
number 4?
okay, so for number 4, you needed to look at question 3. And remember that rate is in molarity per second in this case. Okay? That means your K value needs to be able to take care of this molarity squared and this molarity. So on the bottom you need to have seconds. And then on the bottom you also need to give rid of 2 molarities.
Right.
So molarity squared, which is molarity to the negative 2 seconds negative 1. Okay. Any others on the first side? That's what I just did right there. Number 3. So if you double NO, what does it do to the rate? It squares it. So double 2 to the 2.
Why is it D for number 3?
3 is D. What? Okay. Second page. I was looking for more work than I actually have on here because the work's up here in my head. Okay.
Can you move it down?
Okay. But you should have graphed these two, and I was looking for some sort of an indication that you graphed it or worked it out so that you knew that the slope of this one was straight. Okay. And then on the other side, half-life, you need to use the half-life equation for second order, and then half-life, or the second order integrated rate law, second order integrated rate law. Some of you will notice this, that you got that one wrong, and maybe letter A wrong, but if you took your answer that's here and then carried it correctly through the rest of this, you got credit for these. Okay? So these are the correct answers. If you got 0.986, that is correct. If you got 0.00206 or something real close to it, that's correct. 12.83 is correct. If you don't have these numbers, then you solved the question incorrectly, and most of those are based on that law. So if you said first order, then this changes, and then these 3 change. But if you said first order and then solved that correctly based on, you see what I'm saying? Okay. And then for question 2, you had to use this. There were lots of people with little math mistakes in here. And some of you, you'll notice I said check math. That means go back through and do your math again. But there were several just math mistakes. Some people had this set up correctly, but then that number was not right there. And then the back page, different temperature, half-life, first order, and then first order integrated response. Okay.
Can you like zoom out?
Sure. There you go. So those are the correct answers. Let me give you number 2. And I don't actually. And I really wanted to at least mention the second one with respect to the multiple choice, because I'm sure a lot of you noticed the multiple choice.
Suck. Sorry.
Nice catch.
Right. That's where I did that.
Anthony.
I was even like debating that one too, and like, I asked him like a question, and he like underlined his question. So I was like, oh okay, how's he going?
Yeah, it's just the internet's inside jokes like I don't understand.
I'm really on that part of it. Especially that one. So I was like, yeah.
If these two are fine, and then I get freaking two from all the multiple choices, is that one? Actually, I only missed 2 on here.
Alrighty, so answers for the first set.
Wait, we're supposed to get the test back.
Not that one. All right, so A and B, so number 1 and 2, A and B. Lots of mistakes on B, and it had to do with paying attention to.
Me number 2.
Yeah, number 2. What did I say? Number
You
2.
said me.
It has to do with paying attention to this as a complex fraction, and when you solve this, liter goes on top, moles and seconds on the bottom. So it's liters, moles to the -1, seconds to the -1. Okay. That answer is letter B. few mistakes
Wouldn't
on
you
that.
just like tell like K D is like to a power,
So that it is, it's 1 and 1. And that means that K needs to be whatever in molarity on the bottom and seconds on the bottom. Okay. But you'll notice that there's no molarity as an answer. And you can't do moles to the -1, liters to the -1, because that would indicate it's 1 over moles times liters, which is not correct. That's this. So this question I was asking y'all to think about the complex fraction part of it and understand when you arrange it correctly. This is the way it works out. Okay. And then E, and then down here at the bottom. Here's the mistake. I actually made that mistake too, and then I went back and looked at it. You've got seconds and you've got minutes. And I'm guessing that a number of you selected 0.198, which is the answer in minutes, but I'm after seconds. So you needed to convert 3.5 minutes to 210 seconds, and that gives you letter E as an answer. Okay. So pay attention to details. I goofed out when I first solved it, and then I caught myself and figured out some mistake.
Did you take the test?
I have a bank of multiple choice.
Okay.
questions.
You wrote the question and then got it wrong, because that would be impressive.
Yeah. Well, you saw me pull that
0.133.
Out of somewhere last week. Still don't, Okay. Next page. I want to say that for the most part, 5 and 6 were okay. I think for the most part, those ones were fine. It was letter number 7 that I think, just out of curiosity, who missed number 7? Yeah, it was significant, okay? There's only one thing to focus on in number 7. It's this word. It's the expression. So when you're writing any kind of a K expression, it's products raised to the power of the coefficient divided by reactants raised to the power of the coefficient, whatever happens to be 2s or 1s. It doesn't matter. Where do these numbers come from? Coefficient. And that's the stoichiometry of the reaction. This is the answer. Because it's only asking you about the expression. It's not asking you about what things impact K or the value of K, the constant. It's just asking you, when you write the expression, what does it depend on? Never any talk about the mechanism for these things. The quantities, no. Temperature would impact the constant value, but the only thing that impacts the expression itself is the stoichiometry. So I know that 7, like most of you, missed number 7.
Can you move that back upwards too?
And then the last one.
Thank you.
You're inversed and then squared. So, Ariana, this was kind of your question from earlier when you asked about if you reverse it and then double everything. This one to here has been reversed and doubled. So, inverse and squared. Okay. Thursday, you'll see some equilibrium questions. You'll see some kinetics questions. So, if you didn't do so well on these, okay. And then if you also look in Canvas, there's some of you who will notice that your first test scores don't match what's there. That's because I looked backwards. And if you're consistently improving, then I will replace some of those early scores. Okay. At least in terms of this one then, you should have first order. For what it's worth, I used the spreadsheet to solve these. So I put these into Excel and then said make me a graph. Found an equation, gave me the slope. First order, so that there's your half-life. And again, if you make this 0.7 or 0.007, your answers are going to be different than mine. So keep 3 digits on there. Don't just chop numbers off. I don't care what your math instructors tell you. Don't chop numbers.
They just don't know what cyclics are.
If you use 3 digits, you're going to be generally good. If you just chop things to 1, bad. If you run it out to like 18, bad. If you go 3, you're gonna be okay. 3 rows. Not wacky America's 3.
I can't do it. Look, I can't straighten this finger.
Angela,
Can't straighten.
which one? This one? Say that again. Oh, there you go. Yeah. Is that what you did?
That's what I did, and you marked it down because I didn't see
I brought that show you work, right?
Yeah.
Yeah. So, no, I mean, make a note.
That's where I copied it from.
Make a note, that's fine. To be honest, I didn't even look at the table for that.
Okay.
Once I get this number, then I went right to here, so, I mean, I understand what you did. And that's fine, make a note. Give me the test back. I'll fix that, that's fine.
Okay.
On the back page, you needed to use integrated rate law, first order integrated rate law assignment, solving for a couple different things. Big things here, I just say, some of you check your math. I saw just some math mistakes. When lots of people had setups correct, check your math. Okay. And then down at the bottom, I want to say that this one went, for the most part, okay with everybody. There were a couple of mistakes on these. One thing that stood out, people had brackets in, and it might be a little bit picky, but if I'm after pressure, I want it in P's. If I want it in concentration, I want brackets. They're different. So make sure to pay attention. So if it says in terms of KP, this is what I want. If I said in terms of KC, then you're gonna write KC equals concentration of SO3 squared over the other ones. Any questions on that? Yeah, so Thursday, I'll probably put some kinetics and equilibrium with multiple guess. You'll see an icebox question at least. Shall I put another kinetics problem on there? Yeah, maybe I'll put another kinetics problem. Probably be solved order.
Oh yeah, yeah.
Study out the needs, by the way.
But like with
There was why is that negative? So it's products minus reactants. So it's 2 minus 3.
Okay. For some reason, like a 1. I would say absolute value.
Right, yeah, that makes sense. I was thinking that's probably what you were too, because I actually wrote down one at first and I was like, wait,
that's good.
That makes sense. My math is solid on this.
Right.
We won't talk about multiple choice, but the math is solid.
Hey, that's not too bad though. Like if you